Hello, hello, hello. Welcome, everyone, to this episode of the Julia Dispatch podcast. I'm Chris Rakakis.
And I'm Michael Thiemann, and we have another wonderful guest for us today. Stefan Krastanov. How much did I butcher your name?
No, that was great.
Ah.
So 50%.
Thank you for being here. Thank you for being on the show. I think a lot of people in the community will have read your name at least, because you are the author of the This Month in Julia World newsletter. But before we dive more into this, tell us a little bit about yourself. So you are programming in Julia, but I don't think you're you started off programming in an undergrad, right?
Yeah, around that time. So first, thank you for inviting me. Very much enjoying being here. I already in middle school, I wanted to learn how to program, but I think I found a book on Perl, didn't understand anything. So the time when I actually started doing something useful with programming was definitely in undergrad. I studied in France for my undergrad, where programming classes were focused on Maple, which was fun. They were very much focused on computer algebra systems. And I happened to find SymPy, and a year or two later was even one of their core developers by then. Mm-hmm. So that was really my first encounter with serious programming.
Okay, and I think you have a Master of Science, and this is like a physics and chemistry combined thing. And I think now you're working in quantum networks. So, was that clear that this was the main focus of your interests over the years, or?
Yeah, in high school I was definitely very interested in my physics classes. These were the ones that were most fun for me. In my undergrad was very physics focused. The title of the degree happens to include chemistry in it, and I did have some chemistry classes, but it was very much a physics degree. Mm-hmm. And back then, I mean, I had a very simplified understanding of what academia is, and of course I was absolutely certain that I definitely want to go to grad school and do physics research, and I'll be doing high energy physics. Not that I actually ever did anything.
We all make bad decisions. Yeah.
Yep. Yeah, I was definitely interested in physics, and now I have less of a simplified view of academia, but I did end up pursuing that path.
Okay. And so, I mean, quantum networks, it's physics, but it's also, in a sense, computer science, right? So do you perceive yourself as a physicist with a strong connection to computer science, or do you now perceive yourself as a computer scientist with a strong connection to physics? Or
definitely as a physicist, although now I'm a professor in the CS department. The way I got attracted to this subfield is in physics, there are a lot of really interesting gambits in the way you structure the knowledge and figure out what's happening with nature. Basically, a lot of the really interesting pieces of knowledge come from figuring out what's forbidden and what workarounds are there for what we naively perceive as forbidden. Conservation of energy has to happen. You cannot get around that. Entropy has to increase. You cannot get around that. But now that you have this absolute limit on what's permitted, there is a lot of really exciting research in terms of how do you still squeeze out the most you can technologically out of a system in which entropy does have to increase. And that's how you make better heat engines. And in the last, 40, 50 years, people have started figuring out that purely computational complexity abstract statements can have effect on the physical world. So kind of a quick, silly, simple example is if we have a strong belief that in the physical world it should be unreasonable to expect that you can build a machine that can compute NP hard problems quickly and efficiently, if we have that strong belief, the same way we have the strong belief that energy has to be conserved, then we can say things about what the laws of quantum mechanics can be. The differential equation describing quantum mechanics, Schrodinger's equation, has to be a linear equation. It cannot have nonlinear terms if it is true that we cannot build machines that can solve NP hard problems fast. So that's why I was excited about quantum information science, because purely information science, computational complexity type of theorems can now inform us about what are the permitted laws of the universe. I didn't end up really studying this very high level, up in the clouds type of physics and information theory. I ended up being much more on the technology side, development of actual hardware, control of actual hardware. But the reason I'm excited for all of this is because of this high up in the clouds description of the field.
Mm-hmm. So it's the relationship of quantum mechanics to the theory of computing that drives you, and you're like, okay, I want to build things to try to push the limit because, yeah, I mean, like the theory can tell you what's possible and whatnot, but I mean, just because something's possible, like we actually build the hardware to do this, and so you're kind of in that whole space then of computing quantum, and computing quantum and hardware all to spun together as one.
That's a very good description. Yeah.
Oh, that's pretty cool. Yeah, I actually did not know about like the linearity of Schrodinger equation, how that's related to P equals NP. That's pretty. That's a pretty wild thing that someone could prove.
Yeah, that's gonna. I think when the recording is over, because we do have a plan for what we want to talk about, but it will have nerd sniped me hard, and then I will.
Yes.
when I see you at Julia Connor, so I might get back on to
Yep.
that.
Yep.
So going back to the plan, we always also ask our guests how they dived or stumbled upon Julia, if you will, right? So your GitHub account is older than the why we created Julia blog post. So you have been developing before Julia was around, and then at some point, I think 2019, you started on the package QuantumClifford.jl.
Mhm.
And so around that time, something must have happened. And what was that something, or how did you feel about this since?
Yeah. So I do have this belief that it's not too important to have low-level language. Like you can do fast, cool stuff in Python. And if you structure your algorithms well, sure, the overhead of a factor of 100 from the interpreter, it's fine. And on the other hand, though, I did have situations where I had to worry about that too. So I've been playing with Tiano. This was the precursor of things like PyTorch and TensorFlow and JAX and so on. I've played with Cython. And when Julia came around, I remembered that blog post showing up on Hacker News. I read it and I was sure, great. That will totally work out. I am very happy that I was wrong at the time. It did work out. I'm very impressed that what they were describing in that blog post about something that's reasonably close to the dynamic nature of Python and capable of running as C and having like a pleasant, nice to use type system and like the Lisp heritage of things like Mathematica. The fact that this exists is amazing for me. I loved the idea when it was described in that blog post. I didn't believe it will happen, and I'm so happy that it did happen. So a few years later, when there was actually now something that was not just a very early alpha of Julia, I tried to play with it. It was definitely more pleasant use than Cython. And generally, multi-methods are great. That was one of the big selling points for me. I've been using multi-methods in Python, which are, I mean, it's it's great that Python
Mhm.
can support something like that. Someone just made a library for multi-methods and it works. But in Julia, they're first-class citizen and it's natural and fast to use them. So Julia was great both in terms of performance, in terms of like programming language theory, the way you use it. So I got into it. Funny thing, a lot of the reasons I like Julia is that the dynamical code I work with can then turn into something that's fast. And I've been trying to do stuff like that with Python, especially with SymPy, for instance. And here
Mhm.
I'll probably be poking on Chris. I remember when he announced the symbolics.jl, and one of the main reasons that he created that was because he was so frustrated with how slow Lambdify was.
Yes.
And that's something on which I've spent so much time when I was in 2010, 2011, that type of functionality that converts arbitrary symbolic code into something that you can run with NumPy, hopefully fast. Um, that was a big focus of mine. So the fact that it's so much easier to do something like in Julia is why I got so excited for Julia.
Well, I'm happy because yeah, that was I mean, you know, again, you mentioned like Maple and then SymPy, right? So you seem to have like this deep background with like the symbolic tools, and yeah, for me, that it always looked to me like there was something missing in the symbolic tooling interfaces of like, you know, like, okay, why am I doing symbolics? Well, I mean, yeah, there's this pie in the sky. I'm doing symbolic things to do a math thing, but a lot of times you're doing symbolic things because you want to like create a better form of your equation to compute on, right? And so it's just like, well, if I lambdify out and I get a Python code, then like I will have spent, you know, all this time doing all this symbolic work, and then I get something in the Python REPL that takes, you know, 100 times slower to run than something. I was like, what did I just do, right? So yeah, for me, like that also was like this kind of like, you know, symbolics has to be tied to, you know, a compilation model and compute model. So I'm happy someone else actually wanted this.
Yep. No, one of my big master's projects when I was in Europe, so in my master's was part of my undergrad.
Mhm, mhm,
Uh, One of my big projects in undergrad was for some kind of physics problem where we could generate the symbolics. The symbolics were sums over high dimensional integrals where we had
mhm,
many thousands of terms, and then generating Fortran code out of that, and then running the Fortran code on the compiler for the Fortran code on the cluster because the compiler was crashing out of RAM.
mhm.
Uh, that that was a very fun project. It ended up being high performance and so on. But the fact that you can do that on a laptop with Julia in minutes of compute and compilation time compared to having to use a supercomputer, that was a big deal for me.
Yeah, so was it like the things that were symbolic related that can then brought you into Julia? I mean, because you know, because symbolics came pretty far into Julia,
Mhm.
right? So, you know, and but if you had the symbolic background, like what were the first projects that you started being like, okay, you know, I'm gonna make the jump. Here's the first package I'm gonna write. Here's the first paper I'm gonna try. Like, what made you think like I need to try to use this now?
Linear algebra over things that are not floating point numbers or integers.
Hmm.
And it's not like there was an out of the box. Actually, there was. I didn't know of it. Nemo and the ecosystem around Nemo is amazing.
Mhm,
These are the abstract algebra tools that are like the mathematician's version of a computer algebra system, not our
mhm, mhm,
engineering version of computer algebra system. Those
mhm,
are great. I didn't know of them. I for some of my actual research work, I need to do a lot of linear algebra over weird fields, and with
mhm.
NumPy, that's a pain. With Julia, I still need to write a few kernels, but everything works out of the box. Everything's fast. The linear algebra is not fast only for the special types. It's fast for any type. So that was the big deal for me.
Mhm. Okay, and that's like all the stuff with like Clifford algebras and all that. And so
Yep.
so then Quantum Clifford ended up being one of your early packages there, or was there kind of a
Yeah.
path to get there?
and it was a hobby package basically, and now a bunch of colleagues are using it. So the fact that something I built on the side when it wasn't really my main focus, I had plenty of actual work to worry about, and I put not much effort into it, and it was already something that was unique in the quantum information science ecosystem and sufficiently powerful to be used by others. I think that's a pretty good point in favor of Julia as a tool to use for this type of research.
But by now, I hope that it is closely tied to your research and your actual work, right? So you don't have to support it as a hobby anymore.
Yeah. It was never meant to be something that I'll be advertising when I'm giving a job talk to be hired at the college, but it ended up being good enough that now it is one of those main topics.
Nice, that's cool. Yeah. But talking about hobbies, so you have a blog, and on the blog you also showcase some tinkering with hardware, let's say. And in the talk that we just did prior to press recording, we learned that your students are currently taking an exam in a maker class. So
The
what's
exam finishes in 7 minutes.
okay. What is the what is your favorite hardware project, or like do you have special hardware also as well in your lab that you play around with all the time? And
So my lab is purely theory work. I'm a theorist. I don't do experimental work at all. I don't know how it happened that now I'm the one teaching our lab class. But I do have experience with the hobby type of hardware. Like I do like software-defined radio. I like Arduinos, microcontrollers. I haven't had an excuse to use them in research setting, but in terms of projects along those lines that I really like are those that, I mean, sure, there's all of this maker ethos behind building these things. It's pretty, it's useful, it's easy to get into. But I find it particularly exciting if there's also some mathematical knowledge that lets you build something interesting. So, as an example of that, I was really excited. Gosh, that was in early grad school. That was a while ago. For a project where I made a music box with a laser projector, but the laser projector was made from scratch. And there is signal processing and Julia related stuff coming in. So I had a cheap laser. I made my own Gaussian filter for the laser beam with just tin foil and pinholes and so on. And then on the other side, you had two mirrors at 90 degrees to each other, both of them mounted on copper coils from a remote controlled airplane. So you can control those, and to control them, I had, well, there would be an MP3 player, a music player in the box to play music. And on one of the channels, it will also be driving a waveform for the coil so the mirrors move. And the goal is to project something pretty on the ceiling as you're playing music out of the box. Why I like this project is because there is so much junkyard signal processing, poor man's signal processing involved into it. So just driving the coils with constant sine wave and using paper and marker to mark how big the amplitude is, so you can get the transfer function from the waveform you're putting in as sound into the displacement you see on the laser screen. This was just fun, immediate application of something that otherwise sounds extremely abstract. Like, given the domain in which we are, probably all of us have learned about harmonic oscillators and transfer functions for linear signals. But usually it's so abstract and you don't get to see it. But with this project, I got to do
I mean, I've never seen a piece of foil as a Gaussian filter, so that does sound very real.
Yeah, it was like doing the transfer function with pen and paper and then putting it into something like the Julia linear algebra subsystem or NumPy to get the inverse of it so that I can draw squares on the ceiling. That was fun. So that's my favorite hardware project.
Okay, yeah,
Yeah, that's so real.
Yeah. Wow, I'm baffled. I now imagine like coming to your house, listening to music, and then suddenly there's this great laser show and like.
Yeah, well, I said draw squares. The square is, I mean, back then I didn't know much about proper signal processing. So any windowing functions or Gibbs phenomena that had to be accounted for, I did not.
Well,
but it still worked okay.
I'm just imagining going into your lab and and then you're like, you're just yelling like, where did my Gaussian filter go? And you're like, oh, I used it in the oven. The chicken nuggets are on there. Like, God dang it.
Yeah. Well, in lab we're purely on computers, but this is more
Okay.
in the makerspace.
Nice.
Yeah, I mean, that sounds like fun. That does sound like a nice hobby that kind of connects with everything else that you're doing, and like, yeah, I mean, I'd want to be one of your lab students too if they were doing anything related to that.
Thank you.
We'll take a sabbatical and then just tinker around with Julia and soldering irons. But now for the main event. You are also well known, besides your work in the quantum network package ecosystem, for the This Month in Julia newsletter. And so I had a look at the discourse, and it started with there was a call to action, and here is a proposal to answer this call. That was now almost 2 years ago. How did this came about?
Well, it's Tim Holly's fault. So about 2 years ago, he and a couple of other developers were really trying to deal with one of the big problems that Julia was having at the time: the ridiculously long compilation times every time you launch Julia. So the caching of the code was difficult. And he has some really beautiful explanations for the unique features of Julia that make this into a difficult problem. A lot of people just assume that, yeah, of course, you just compile the code and save it. Like, why are you throwing it out every time? Julia's the dynamic nature makes some of these things difficult. The programming theory behind it is really fun and interesting. But anyway, they solved that issue. And around that same time, though, there is a lot of frustration, the typical type of frustration you have in open source communities, where there is some push and pull from folks that are using the tools, but don't necessarily have good understanding of the fact that this is an open source project. This is a volunteer run project. And a lot of frustration about the fact that, hey, you guys are doing all this cool stuff, but why didn't anyone tell me about it so that I don't give up on the project? I imagine Tim was pretty frustrated by this, because if you
Tim's never frustrated. He's just always a happy dude. But
yeah. But anyway, at some point, in a very constructive and very polite fashion, he basically tried to describe that, hey, we're doing a lot of difficult work here. We want you to know about it, but this is exhausting. Someone should be helping here. If you want to know about this, why don't you lurk a little bit on GitHub and see what's happening? And at the time, I was trying to avoid Reddit. So instead of Reddit, I was using the Julia GitHub. And I happened to know about these things because that was my way of procrastination. And I decided to try to procrastinate a little bit more productively, and posted the list of things that were curious to me. it worked out, and now I try to do it every month.
Did it turn into? I mean, it sounds like you're just almost doing it as like a fun thing. Like, I wonder, like when you started, like, yeah, I'm going to, I'm just going to start doing this every month. Like, did it turn into a lot more work than you expected, or did it just
Uh,
end up like, oh, still my free time? Oh, I just read all these articles. Yeah, of course these are the ones to put here.
a bit in between those two. Like I already on the first post, and I think I kind of repeated on future posts as well, said along the lines of, "Hey, I am doing this on best effort. So if someone else can help, please go ahead." I frequently I am more than a week late to upload it. So on some weeks, on some months, it has been a chore to get to it. But I still extract value from reading from lurking on the Julia GitHub. So most of the effort is really just copy pasting into a Google Doc, which is no effort at all, and then maybe 2 or 3 hours a month to just format things. And now there are people that double check on my formatting. So you notice that every time this is posted in the next 2 days, there are edits to fix typos and misstatements.
I mean, would you recommend that the average Redditor instead just reads a pull request in the Julia Lang repo?
Yeah, definitely. Much well. We should be careful to not get one of those endless summers
Okay.
failures.
Yeah.
But no, it definitely helped with my procrastination.
It's a very productive procrastination, that's for sure.
Yeah. It's amazing.
To be fair, a lot of the compiler stuff and a lot of other stuff is way over my head when I'm reading those pull requests.
So do you like, pull people up, interview them, and try to figure it out like that, or you dive right
Uh,
into it?
I usually I don't post much on Slack or anything, but if I post, usually it would be in the internals sub channel, just asking, "Hey, can someone explain this in like 2 or 3 sentences for like I'm 5?" Because it seems fun, but I really don't understand how it fits in the big picture. I want to put it on the newsletter, and then I just copy paste the explanation.
Mm-hmm. So how much of what you find then is like things that you're like, oh, this is cool, and the things that you're kind of going, and how much of this is kind of pointed to you? Because now people know that you're, you're the new monthly newsletter guy, right? So how much do people actually kind of go to you and be like, hey, look, check this out. This is a cool thing to be adding, and like, oh, look at this project over here, this PR.
Maybe uh, maybe 1/4 is just things that other people drop on the Google Doc, and they really don't need to check in with me. They just post it, and I mean, once or twice I might have deleted something because it was too niche. If anything, it kind of hurts when I feel like I have to delete something that's on quantum information science, because there's some really niche developments on quantum information science that I end up deleting. But yeah, most of the time, especially for internals, um, someone else posts some clear description. So that, I guess, kind of fulfills the initial uh, um, community frustration to which Tim was responding back then, that the core developers don't post much. Well, now they post 2 sentences. I fluff them up a little bit, and that's it.
Yeah, they'll post like just like fixes a lot of bugs link, right? And you're like, okay, about what? And you have to figure it out a little bit, but okay, yeah.
No, it's better than that. So
Okay.
they're giving sufficient detail. I guess it's just that there's a venue on which to give a quick, short announcement. Just the existence of that venue, I think, made it easier for people.
Mm-hmm. Yeah,
So
well, I'm just harkening back to I remember when I was doing some reviews of some of the JuliaCon submissions, and I remember one of the birds of feather that was put together. I think it was the compiler team for like a compiler birds of feather, and it was compiler birds of feather abstract. It's on the Julia compiler. And so the reviewer is like kind of like knocked down the thing. I was just like, oh,
Yeah.
okay, like we'll bump this thing back. Jeff, you need to just write a better abstract than just 5 sentences here. So it seemed like like it's definitely a crew that's not always the most verbose. I'll say I'm a talker, but it's a different group.
Yeah, I would love to know how. Like, I've seen, especially on internals, a few new folks coming up every so often. Like, how did they get into it? I'm seeing what they're putting in, and I really have trouble figuring out where did they read the documentation about how things work. Are they just really good developers that just read the code and it was clear to them? Because it's a sure, locally I frequently can understand the code, but I completely lack the big picture, and I don't know where I can get the big picture.
I actually, so when I procrastinate, I also like to look at the source code of the Julia internals, and no matter how often I sometimes I try to understand the pull request. Sometimes I just dive into the code base at some random point, and I haven't been able to get the picture yet. I do assume by now that the developer documentation is a little bit out of date with the actual state of the code, and I think that is one of the problems that I have trouble, because I also tried that route and I didn't completely got anything, but who knows. It's a fun world, definitely.
Yeah, well, I hear that there is going to be a doc update around like the compiler interfaces, so that way all this new stuff about being able to inject things in compiler, and it's like, oh, this is going to get updated for that. So, but yeah, I think the last major update on that piece for that developer docs might have been like 2020 or so. I remember there was a big push to put it out there. It's like, oh, we don't have a developer doc section, so we should write this portion, right? And I think that it got written one time, and it probably hasn't been updated since. But but I do know I've been pushing a few people on like, I really want to know how to write compiler plugins for AD stuff and such. So can we get this into here? It's like, oh, we got to rewrite the whole page. Yeah, it's like, yeah, can we do that?
And if I may plug this here shamelessly, I think if new people want to join with just getting their first pull request, updating documentation and trying to just understand what's happening and then writing it down for others, while they're also in this fresh state of mind where they not have like the um, enlightenment picture of, oh, everything is so obvious I don't even write it down anymore state, that is very valuable for newcomers. Always open pull requests with documentations will always be welcome. My 2 cents.
I guess, yeah. So one of the other things, I mean, one of the other things that Mike put in these notes here to ask is whether anyone hasn't done any bad faith acts to the Google Doc. No
Nope, nope,
vandalism or
not
anything.
yet. Now, if anything, I'm a bit worried now that you're mentioning it. Maybe
Yeah.
there will be Rickroll links.
Yeah, so yeah, you're just gonna get rickrolled all the time now.
No, it's been great.
But it's I'm still amazed that, like you said, like a quarter comes from someone who writes in the Google Docs, but the most of the stuff is still you just looking at the pull request. Like how do you identify the sparkling ones? Like are those the ones that have the longest discussion, or are the ones with like the most edits, or is it just from the topic that it's clear, okay, this is something juicy? Or
The Slack channel appreciations, gripes, and gripe appreciations, and internal. Those 4 Slack channels are very, very helpful in identifying something that's interesting, especially gripes. And then usually if something is mentioned both on Slack and it has a GitHub discussion, if it's mentioned on a couple of places, I specifically look at it. But then at the end, anything that's the newsletter has two sections: the internals and the ecosystem. Those are the kind of the main sections. For the ecosystem, is very straightforward. Like there is package announcements and so on. Especially some of them are more interesting than others. For the internals, I would say it's more difficult to figure out what to put in. Um, every so often, something just because of the ridiculous naming conventions that people use just flies over my head. If anything, I think Keno is really bad at this. He uses really fanciful terms for things that seem to be explained much more straightforward otherwise.
Oh,
So
if you know category theory though, then it's straightforward.
yep. So if Keno has a pull request, I usually try to look at it and then I ask on internals about what it means. Those usually get put in. If any of the Jet developers or any of the, at this point I just know the names of the people that do kind of big contributions. So I know to look more closely into those. So those usually won't get dropped. The bigger problem is when there's a new contributor, where again I am not domain specialist here, so I don't recognize their name and I cannot judge their work until there is a discussion on the pull request. I cannot really judge whether this is exciting for the community or not. And also, uh, at this point, probably I'm maybe a little bit above average in terms of understanding these internals. But the newsletter is supposed to be the exciting things to look forward to in terms of what you, the user, will get to have, not the low level details. So the biggest problem for me is when there is a pull request that's obviously a big deal, but there is no public discussion about it, so there is nothing to point people to read and understand. And I don't have the time to be the one writing this discussion, especially because I probably will do it wrong. So those are the difficult ones.
The ones that say we did some cleanup in the backend, and for you nothing will be changing whatsoever, but it will help us move faster in the future. It's like
yeah, something along those lines. This particular example, I'll probably just skip that. But if it's something that has interesting programming language theory behind it, or the whole notion of world ages and tracking of bindings and so on, this is really cool stuff that now is enabling revise to revise over structs and so on. But some of the first pull requests on this, they were very esoterically written and there was nothing to link to so that others can know what's happening.
Yeah, I think I only started hearing about it because I saw Jameson in The Office, right? And he was, and like I think we were talking about like the strange instructs. He's like, "Oh yeah, I've got things, that's easy to solve. I got a plan for that." He shows like a PR, just like, and the PR is just like, change recursive bindings. I'm like,
exactly.
right, it must be.
Yeah, that's the main problem in popularizing what's happening.
By now, as Chris said earlier, you are the monthly newsletter guy, right?
He is the monthly newsletter, not even just the guy. He is the monthly
Oh
newsletter.
gosh, that's terrifying.
So how do you feel about this? Like, is it is it exciting when people want to talk to you about this, like we on the podcast, or people come to JuliaCon, or would you rather, hey, I'm doing cool quantum network packages, please associate me with that first, and then also the newsletter?
Definitely the latter. Definitely preferring to think about the actual science and development work I'm doing. But community work is important. Like that's how things move forward. And I mean, I imagine that's partially how this dispatch works here as well. So
yeah, we're here to share everything about everybody.
Yep. That's really it.
Okay. So then we'll make sure that you'll come back and also get a good chance of taking us through the quantum networks.
Well, I
although
want to
you
see the Hobbymaker projects you got going, right? Like let's like turn the video around and show the actual project. Like that'd be
Yep.
some cool stuff. Like, have you ever thought about doing some content creation on that? I mean, like not going to like the level of like Mark Rober or something, but like just like creating a video of like, oh hey, look, I made this hardware and everything, and here's the code with it. And like showcasing that whole, because I feel like that would be like just like I would watch that video through 30 times.
Uh, I do a version of this more in terms of science outreach. So
Mhm.
in grad school, I was organizing events where we would have 200 middle schoolers on campus, and we'll have them solder, and then their parents will be in the next room, and we'll be giving the parents some suggestions about activities, science activities they can do with their children. And we
Mhm.
tell them, oh, by the way, your children are in the next room working with actual soldering irons. And just the pleasure I was extracting from seeing their terrified faces, that was fun.
Yeah, they're playing
Uh,
with mercury right now.
yep. No, because of the European Union, there's no mercury in these things
Okay.
anymore. No lead either.
Mhm.
But yeah, I do a lot of that type of stuff. So designing kits, lecture materials. Uh, during during the first week of the COVID shutdown in the US, I released a Kickstarter on some small educational kit related to Arduino, something about motion sensing and color theory. It was basically a small piece of electronic jewelry with motion sensing, with lights. It was a very good platform on which to teach about everything from programming to physics to art. So that type of stuff I'm pretty involved in. I have a similar project right now, but the ones that come more naturally to me are more local, not YouTube style, but make a kit, have a few
Mhm.
kids to hear. Uh, not to disparage someone like the YouTubers you mentioned, like the summer schools they've set up for from some of their channels are absolutely amazing. They're definitely having much wider reach. But for me, the local ones work a little bit better.
I
Mhm.
mean, it's amazing, I think, that that you'll get this enjoyment out of the direct interaction, and so you're doing this, but still, right? It's all the contributions that move the world forward, and okay, this is one that I can do it. It probably even gets you back the energy that you put into, right? And
Yep.
so, I mean, that's
Yep.
great.
Yeah, my favorite all-nighters have definitely been before the night before an event like this.
That's cool. So one other thing that that came to me in the preparation of this episode was, so the I was assuming the reason that this monthly newsletter works so well is because Julia is still a very small dedicated community, right? And there are other programming languages like Python and MATLAB and R and what have you, who are just so big. They offer everything that it's kind of hard to tell what would be interesting to everyone. Now, I'm still hoping that Julia will join this club of very big programming languages. What do you think the newsletter will look like with the growth of Julia?
The ecosystem section probably will be difficult to still keep consistent,
Mhm. Mhm.
but I'm really not worried about the internal section.
Yeah.
Uh, like the same way I am now procrastinating by reading GitHub, the Julia GitHub. Uh, 10 years ago, I was reading the Python PEPs, the what
Mhm.
was it, Python enhancement proposals,
Mhm. Mhm.
and I, I mean, they're structured differently from a newsletter, but it was fun to see suggested new developments. And a Python news, I am sure that exists. A Python newsletter that just discusses PEPs. That would be a fun, interesting newsletter. Even though Python is such a ridiculously large ecosystem now that plenty of people don't care at all about the core language. That's where I view potential future version of the newsletter, just focusing a little bit more on the internals.
Mm-hmm. So you'll stay. Do you have do you subscribe to the Julia Lang / Julia repo and get that in your email every
Oh
single
no,
day?
no, no! That would be painful. I basically every other week I just look through what's merged and what's. I just sort by what's most recent.
Okay, so you it's still at this level that like there's a ton of activity. If no one's ever subscribed to, just go subscribe to it and get in your email for one day, and you'll know what we're joking about, right? But yeah, I mean, if you so it sounds like you're like, okay, there's already way too much in here for any single person to read, but
Yeah,
you can go through with the things that merge really quickly, be like, okay, that headline looks interesting, and then also go over to gripes and say, okay, what are now people griping about, and the connection between those two becomes the newsletter. It sounds like that's the kind of
that's
the
pretty much it.
simple. Okay, cool.
All right. So let's also take the opportunity to talk at least a little bit about quantum network. So I think there's Julia Summer of Code proposals open. I am not completely familiar with the process. Like, are the topics still open, or are there already students
I
that
think they were due
are?
today, right?
Yeah,
Yeah.
the deadline was last night, so today we're already reviewing them.
Okay. And so do you know already whether there will definitely be someone working on the packages this summer?
I think so. So this is just within the Julia project. I imagine SciML has a bunch more, and there are a few other Google Summer of Code Julia related entities. But just for the Julia Google Summer of Code entity, there are 80 proposals, and about 8 or 9 of them are quantum information science specific, which to me that's exciting. That's significant growth from previous years. And the thing is, all of them are strong, so now I have a problem. I think we'll probably just fund some of them independently through the Center for Quantum Networks. I think I'm hopeful that most of these projects will move forward, either actually through Google Summer of Code or through independent funding from the Center for Quantum Networks.
Mm-hmm.
Okay, cool. And so are there any most exciting features that you're hoping will get done this summer?
Yeah, so 3 big groups here on the things that I am potentially a mentor on. I have a few colleagues that would be mentors on other topics. They're probably excited about other things within the quantum information science ecosystem. On my end, a lot of GPU acceleration work being proposed, which in Julia, it's so pleasantly easy to do it compared to other places, like especially with the kernel abstractions library. It's working with an AMD GPU is probably the easiest with Julia, although AMD doesn't invest in the Julia ecosystem. That's just mind-blowing to me. Then a lot of work on collating error correcting codes, quantum error correcting codes, and benchmarking techniques for them. There is a lot of really sophisticated abstract algebra in the style of Nemo.jl and Oscar.jl for building literally just parity check matrices for error correcting codes with very weird locality and connectivity properties. And you need someone with a lot of domain expertise and Julia skills to be able to create these databases of algorithms that create these parity check matrices. There are a few projects on that topic. And then there are a few projects on specific simulation algorithms. There are a lot of efficient simulation algorithms for quantum systems that can run on classical computer, but they cannot simulate a general purpose quantum system. They simulate some very restricted quantum system, and there's a very large family of them because there are many trade-offs you might need to pay. And you really need a large family of those simulators in order to be able to jump from one to the other to the next one, depending on what's the problem you want to deal with. Usually you need a bunch of very different algorithms. And yeah, there are a few projects in that direction as well.
Cool. Okay. So we'll have you back probably, or maybe after the summer, and then you can tell us all the things that happened. That sounds awesome.
Yeah, we get the whole crew together, and yeah. Well, I mean, we'll have to figure out what we should do about GSOC this year. Like, you know, we might want to get all the mentors and people on for different projects. So it sounds like you'll have a whole crew. So you know, that'll probably be if I would like to talk to the whole group, and then we could see if you know if all the students are as excited about the same thing you are. If they're like, no, actually, the Intel GPUs is actually what it's all about. Like, why AMD? Intel GPUs are where it's at. Right?
Yeah. So as someone who has a very superficial understanding of quantum computing, I mean, quantum computing is in the news a lot recently. What is your guess where this is going? Like,
is quantum supremacy next year?
No, that happened a few years ago.
Okay. Oh, okay. So explain. I mean,
Yeah,
this is something that a lot I have that conversation a lot because a lot of people say like, oh, quantum supremacy. Like, when is it actually going to be on a real problem that is a real demonstration of it, right? So if you're in the field, and you're saying it's already happened. I'd like to hear a lot more.
Well, with a lot of caveats. So there is definitely a lot of unreasonable hype in the field. And on the other hand, there are also a bunch of things that I think are super exciting that there is no hype for within this field. So in terms of quantum technologies, it's not just computing. There are interesting applications, especially in sensing and just sensing beyond the noise limits that you're capable of doing classically. A lot of things that would be about building hardware based on quantum technologies for other scientists, for people that want to measure gravitational waves, for people that want to detect very subtle movements of the Earth. Plenty of both purely scientific and economically interesting applications. But let's go back to quantum computing. You wanted to say something?
I was going to say like, okay, yeah, because you made a distinction there that I hadn't actually heard before, which was hardware based on quantum sciences, which is not necessarily quantum computers, but it's like it's hardware that uses quantum effects to be able to sense things and such.
Yeah.
Okay.
I mean, one kind of on the nose way to talk about this is that the transistor is based on quantum effects. So any classical computer, but the point is quantum effects that you can harness at the single particle level. So there are really interesting types of new sensors for magnetism that will provide way better MRIs or way better calibration between remote clocks for better GPS, calibration between remote devices for sensing light in telescopes, gravitational wave sensing, and so on. All of those are developed by the same people that develop quantum computing hardware, but they're not under the hype umbrella of quantum computing hardware. And if anything, a lot of these things probably will have economical effect, positive for humanity, sooner than the quantum computers. But funding the quantum computers kind of also makes it possible to work on these more near-term sensing platforms.
Yeah, that's definitely something that was not on my radar. So that's pretty cool. Yeah, I'll have to. You've nerve signed me on a few things already. Like I have a whole list of things to Google right after this. But then on the quantum computing part, though, you also had something to say there.
Yeah. So you kind of alluded to it. We already seem to have examples for really contrived, scalable digital problems. Those words kind of matter here, where experimental quantum device that I won't necessarily call a full-blown computer yet, performs better than any digital or analog classical hardware that exists. The problems are completely contrived, but they're not economically useful. They're not scientifically useful. They're, let's Monte Carlo sample from this really weird probability distribution with really weird correlations in it. And the classical algorithm for sampling from that probability distribution is expensive, much too expensive. The quantum one works out well. No one would ever care to sample that probability distribution for any practical reason, though. The problem was designed to be an actual computational complexity abstract problem, so that you can talk about scaling with respect to the problem size, a problem that needs the notion of reprogrammability, so that you can talk about this being a computer, not just an analog simulation. And it was designed to be difficult for a classical computer and easy for a quantum computer. So it's a tech demo. It's an extremely exciting tech demo for a mathematician, but it's just a tech demo. And if anything, it's difficult to find problems that are of practical interest, that are difficult for classical computer and easy for a quantum computer. The mere fact in terms of computational complexity theory that such problems exist is theoretically incredibly interesting. Like, why would that be true? Why is there this really weird sliver between truly difficult problems like NP-hard problems and easy problems like P and BPP problems? Why is there this sliver in between those two for things that are easy on a quantum computer but difficult on a classical computer? That's an interesting theory question. But then there's the question of, is there something of economic value here? And there seems to be, like simulating inherently quantum mechanical processes like chemistry, protein folding, high energy physics. Those someday, these things will be made way easier thanks to quantum computers. The supremacy in the sense of solving that type of problems probably is still a while away. Entities like IBM and Quera on their roadmaps, and they've been reasonably good about following their roadmaps, say 2030 will be the first inklings of when we're providing economical value by solving these problems.
I think that's probably the most reasonable, balanced description I've heard from someone who knows the subject. So I'm glad we got it recorded.
Perfect.
And now if the economic realization of quantum computing gets more and more present, let's say, and the war for talent is sucking in everyone that is somehow related to quantum computing and offers them like perfect conditions. Like, is there a scenario where you would consider to join industry but would still be associated with Julia or still do teaching, or how would that look like? Or is
How much
it's
money
just
do you have to be
never?
offered before you just leave your students right in the middle of their test, and then you're like, I'm out of here, I'm going to industry? Like, quantum computing's where it's at.
I don't know. I'm not saying that I should be paid that much. I don't think it's reasonable for anyone to offer that much for me, but I don't know, at around $10 million a year, I might consider that, because then I can,
Query, you know your price.
then I can put that money back into something fun.
So it sounds like then, like the you're putting a pretty high price to it. You'd say like, okay, I love what I'm doing here with academia, working with the kids and everything, and so you prefer to stay there rather than going to the industrial side and quantum computing, no matter how much the market is taking off.
That was kind of the point of saying this preposterous number.
So that means that because you're able to work on this newsletter by being at this academic position, that we're going to have you for quite some time, right?
Well, I might burn out from the newsletter at some point. So if anyone's listening, definitely consider helping.
All right, that's the call to action right there. If you thought that this newsletter was great, it sounds like all you have to do is you just have to read all the gripes that people are posting and just like find out what PR they're actually griping about, right? So
Yep.
it sounds like a lot of people could help here. You don't have to know everything about the compiler. I think that's one of the big things, right? You don't need to know everything about the compiler. Sounds like you got a system where you've been learning more and without having to know everything going on, and so other people who are just kind of curious could get in and help as well. It doesn't take like a core compiler person to do this, so that I think that's a nice call to action to go with, like your methodology there.
And
That's perfect summary of it. Yes.
And in particular, like it immediately comes back to my head. Like I was trying to get off Reddit and do something more productive, like procrastinating reading the gripes channel or reading the appreciation channel or the gripe appreciation channel, and then just remember, oh yeah, Stefan told me to also write it down if I can associate it with the PR. It would help you, it would help the community, and it sounds like a lot of fun, to be honest.
Yep. I'm all for optimizing into low effort, high impact procrastination.
Oh, I like the statement of, yeah, instead of reading Reddit, you could just read gripes.
Excellent. Is there anything more, Chris, from your side?
I think that's everything from my side. I mean, I think that we could definitely do another episode where we dive deeper into a lot of what you've done with symbolics and the symbolic quantum algebras and everything. Like, to me, that could be a fascinating topic. But I do think that this is about at the hour for, and I think we got everything on the newsletter. So yeah.
I agree, and I to be honest, I just have to do a little bit of nerd sniping now that the quantum network is just a tiny little bit clearer to me, and then we will have you back on to talk about the thing that you're really passionate about. But just at this point in time, thank you so much for being on the show, for taking your time, but also a huge thank you for doing this very valuable work to the community.
And same to you guys. Thank you for the invite and for all the work you guys are doing.
Oh, I'm just talking in a microphone.
Sure you are.
All right, then, let's hear and see you in the future.
Yep.
Ciao.
Bye-bye.
Bye, everyone.